Welcome to the Advanced Software Architecture course. This is a lecture on Design Principles, Part 3. In the previous video lectures, we presented the first group of design principles. The goal of this lecture is to get familiar with the rest of the design principles in software architecture. Every design principle will be presented with an example, and you will be able to test your understanding of the topic with an appropriate quiz. Design principles. There are several important key principles that should be used in all phases of software development. The last set of principles will be covered in this video lecture, and they are cohesion, coupling, dependencies, and keep it simple. Let's look at the principle of high cohesion. Cohesion refers to the degree to which elements of a module belong together. A system or module has high cohesion if it keeps things together that are related to each other, and moreover keeps things separate that do not belong together. This makes the system as a whole easier to understand and change. As a rule, each module should be highly cohesive, meaning all the components inside a module are related. Low cohesion is bad because it indicates that there are modules or functions in a module which have little to do with each other. Modules whose elements are strongly and genuinely related to each other are desired. Let's look at an example of cohesion. This design principle applies to all levels of software design. The example on this slide illustrates the cohesion principle at the level of an individual class. In the first picture, all methods with the class employee are not related, but in the other picture, the methods are very well related with the attributes of the class itself. They are cohesive. Let's look at an example of cohesion. The examples on this slide illustrate the cohesion principle at the level of components. The components in the design on the left are not related, so there is low cohesion. In the design on the right, the components depend on each other and interact with each other. They act on the same data and have related functionality. Hence, they belong together and there is high cohesion. Let's test your understanding of the cohesion concept. Please have a look at the designs on the slide. Then select a solution that presents an example of high cohesion. Let's look at the principle of low coupling. Coupling is a notion that relates to the interdependency between modules or components. Coupling occurs when there are dependencies between one component and another. And coupling characterizes how dependent one module is on another component or the degree of dependencies with other components in the same module. So there are two aspects to coupling. Firstly, there's the strength of the dependency between two components, and this can vary. The more one component knows about another component, the higher the coupling is between those components. And secondly, a larger amount of dependencies between components implies a higher coupling between them. If a system has many dependencies and hence a high coupling, then this makes it hard to see how components work together. Moreover, coupling can occur in different stages of software development. There's runtime coupling. This takes place at runtime, and you can see it through service calls between components. There's also develop time coupling. This represents relations between components during development. This can be seen if components are both needed in order to do a successful compilation of a system. As a rule, low coupling is good because it minimizes the impact of changes. If there are few dependencies from one module to another, then this means that change in one module are less likely to require a change in another module. Hence, a developer can understand and make a change in a module in isolation. Let's look at an example of coupling. On this slide, we see example A and example B. Example A is clearly an example of high coupling. The components in the figure have too much connections, and they can be avoided by a better architecture design. Component B shows the same design but with a low coupling. Here is a question about coupling. Have a look at the diagram and please select the diagram whether it has a high coupling or a low coupling. Let's look at the next principle related to coupling. This principle says that we should avoid circular dependencies. A circular dependency is a relation between two or more modules which either directly or indirectly depend on each other. Why are circular dependencies bad design? Firstly, it is difficult to understand and change each module in isolation. Secondly, tight coupling of the mutually dependent modules reduces or makes it impossible to separately reuse each module in isolation. Thirdly, circular dependencies can cause a domino effect when a small local change in one module spreads into other modules and has unwanted global effects. Here's a question about circular dependencies. The slide shows 3 designs. Please choose the design that should be avoided. The next principle is about the direction of dependencies. Dependencies should go in the direction of higher stability. That means components that are less stable and more likely to change should depend preferably on components that are more stable and less likely to change. This is a way to limit the amount of changes to the system and limit the impact of changes as much as possible. To reason from the other direction, suppose it's the case that B changes more often than A. Then, because A depends on B, every time that B changes, we must also check if A must change. Apparently, there is no good separation or abstraction at the interface from B to A. Let's test your understanding of the concept of dependency. This slide shows 2 designs with dependencies in different direction. Please select the design where the dependency is in the correct direction. The next principle we'll discuss is the KISS principle. It stands for Keep It Simple. Simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. And to make matters worse, complexity sells better. This is a citation by Edsger Dijkstra. In general, the Keep It Simple principle states that the best system design is a simple design rather than a complicated one. Therefore, simplicity should be a key goal in design and unnecessary complexity should be avoided. It is actually generally easy to recognize a mess, and in this you can trust your judgment. If a design looks like a mess, it probably is a mess. Summary. After this lecture, you should be able to understand the group of design principles related to dependencies, coupling, and cohesion. Also, you should be able to apply these principles to a design and to recognize if they are violated. Lecture Design Principles Part 3 is finished. Thanks for watching.